There is something buried beneath the moon that should not be there. It lies beneath the largest impact crater in the solar system. A mass so dense that it's deforming the lunar surface by more than half a mile. We know it's there because the moon's gravity gives it away. And in 2019, China landed directly above it. What China uncovered doesn't align with existing models of the moon's interior. So, in this video, we're looking at what China actually found on the dark side of the moon. The other face of the moon, the one we can't see from Earth, is called the far side. Some people call it the dark side, but that's a bit misleading. The term doesn't refer to darkness in the sense of light. It refers to mystery because we can't see it. We can't communicate with it. Radio signals travel in straight lines. When you send a signal from Earth to a spacecraft on the far side of the moon, that signal is blocked by 2,000 kilometers of solid rock. There's no way around it. The moon itself acts as a barrier. This is why no spacecraft had ever landed on the far side until 2019. It's not that we lacked the technology to get there. It's that we lacked the ability to control a spacecraft once it arrived. The solution is a relay satellite. In 2018, China launched Kuaiyou, which means Magpie Bridge. The name comes from a Chinese folk tale about two lovers separated by the Milky Way. Once a year, magpies form a bridge with their wings, allowing the lovers to reunite. Kuaiyou was designed to do something similar for spacecraft and Earth. The satellite doesn't orbit the moon. Instead, it sits at a special point in space called the Earth-Moon Lagrange point. This is a location about 65,000 kilometers beyond the moon where the gravitational forces of Earth and the moon balance out. A satellite placed there can see both Earth and the far side of the moon at the same time. The idea isn't new. It was first proposed in 1966 by Robert Farquhar for the Apollo program, but no relay satellite was ever launched for Apollo. The far side remained unexplored. China was the first to make it work. On May 20, 2018, Kuaiyou launched from the Xichang Satellite Launch Center. It took 24 days to reach L2 using a gravity assist at the moon to save fuel. On June 14, it entered its final orbit and became the first lunar relay satellite ever placed at that location. Everything was ready. 7 months later, Chang'e began its descent. The landing site was the von Karman crater located inside the much larger South Pole Aitken Basin. The South Pole Aitken Basin is not just large. It's the largest confirmed impact structure in the solar system. It's roughly 2,500 kilometers in diameter. That's about the distance from Texas to Washington, D.C. The crater, Music, is so big that you can't see all of it at once, even from orbit. It formed approximately 4 billion years ago when a massive object, possibly the size of a small planet, collided with the moon. The impact was so violent that it may have excavated material from depths as great as 200 kilometers below the surface. Scientists believe the collision might have exposed the moon's mantle, Music, the layer between the crust and the core. If true, this would make the basin one of the best natural laboratories for studying the moon's interior composition. But there's something else down there. In 2019, researchers at Baylor University analyzed data from NASA's Gravity Recovery and Interior Laboratory mission known as GRAIL. The mission used 2 spacecraft orbiting the moon to measure subtle changes in its gravitational field. When they combined that data, Music, with topography measurements from the Lunar Reconnaissance Orbiter, they found something unexpected. Deep beneath the floor of the South Pole Aitken Basin, there is a massive concentration of material. The anomaly is so dense that it's weighing the basin floor down by more than half a mile. Peter James, the lead author of the study, described it this way. Imagine taking a pile of metal 5 times larger than the big island of Hawaii and burying it underground. That's roughly how much unexpected mass they detected. There are 2 possible explanations. One is that the metal core of the asteroid that created the basin is still embedded in the moon's mantle. Computer simulations suggest that under the right conditions, an iron-nickel core could be dispersed into the upper mantle during an impact and remain suspended there, Music, for billions of years. The other possibility is that the mass represents a concentration of dense oxides that formed during the final stages of the moon's magma ocean solidification. Either way, it's strange and it's exactly where China decided to land. Chang'e 4 entered lunar orbit on December 12, 2018. For 3 weeks, it circled the moon, refining its trajectory and preparing for the final approach. The landing was scheduled for early January, but the exact timing was kept secret. Prior to confirmation, many details of the mission had not been disclosed. On January 3, 2019, at approximately 2:30 in the morning, GMT, Chang'e 4 began its descent. Starting from an altitude of 15 kilometers, the spacecraft used a rocket booster to decelerate. This is normal for lunar landings. There's no atmosphere on the moon, so parachutes don't work. You have to burn fuel to slow down. At 100 m above the surface, the probe briefly hovered. Using a high-tech camera and laser measurements, it scanned the terrain below, identifying obstacles and measuring slopes. The surface of the moon is not smooth. It's covered with rocks, boulders, and impact craters of all sizes. Landing in the wrong spot could mean disaster. Chang'e 4 selected a relatively flat area and resumed its descent. It touched down softly in the von Karman crater at 2:26 Greenwich Mean Time. The first close-up images of the far side began transmitting through Quayo shortly after. NASA Administrator Jim Ben-Stein called it an impressive accomplishment. Martin Weiser, a scientist at the Music, Swedish Institute of Space Physics, said it was uncharted territory and that made it very exciting. But the landing was only the beginning. After the solar panels and antennas were deployed, Mission Control in Beijing prepared to release the rover. The rover's name is Music, U-22, which means Jade Rabbit in Mandarin. It's the second rover China has sent to the moon. The first U-2 landed on the near side in 2013. U-22 is small. It weighs about 140 kilograms, Music, and stands roughly 1 m tall. It moves slowly, traveling at a maximum speed of 200 miles per hour. But it's equipped with sophisticated instruments, a panoramic camera, a ground-penetrating radar, a visible and near-infrared spectrometer, and an advanced small analyzer for neutral atoms. Its mission is simple. Drive around, take pictures, analyze the soil and rocks, send everything back to Earth, and then it found something unexpected. In the early 2022, scientists analyzing images from U-2 noticed something unusual on the surface. 2 translucent glass spheres sitting on the dusty lunar regolith. They were small, between 15 and 25 millimeters in diameter, roughly the size of marbles, but they were different from anything that had been found on the moon before. Glass has been spotted on the moon in the past. The Apollo astronauts brought back samples of it. NASA's Apollo 16 mission found glass chunks near an impact crater on the near side, some as large as 40 millimeters in diameter. But those samples were opaque, dark, solid. The spheres found by U-2 were translucent. You could almost see through them. They glistened against the dry, gray landscape like small pearls. Zhang Xiao, a planetary geologist at Sun Yat-sen University and Music, one of the lead scientists on the Chang'e 4 mission, said the globules simply blew their minds. They were so unique on the moon. Glass forms when silicon-rich minerals are rapidly superheated. On the moon, this typically happens during a high-speed impact. When a meteorite strikes the surface, it vaporizes rock. The molten material is thrown into the air and as it cools in the vacuum of space, it solidifies into glass. Scientists call these microtektites. They've been found on Earth around impact sites. Upon being struck by a meteorite, chunks of planetary crust are thrown up into the air. The molten silicate minerals contained within combine to form tiny glass beads that are sprinkled over the surrounding landscape. The microtektites discovered by U-22 are larger than those typically found on Earth, but they are smaller than the glass chunks found by Apollo 16, and they are transparent. The researchers believe the spheres were made from anorthite, a feldspar igneous rock that melted and reformed in the immediate aftermath of a meteor collision. Anorthite is common on the moon's surface, especially in the highlands. But what's interesting is what this discovery suggests about the moon's composition. Shirao described the spheres as the first discovery of macrosized translucent glass globules on the moon. He said it confirms that lunar and ortho sites are excellent raw materials to manufacture glasses with good light emission.